In this section, we'll take a look at building your first neural network. In this section, we'll get an introduction to neural networks. Then we'll create a neural network with PyTorch sequential. We'll look at activations, loss functions, and gradients, forward and backward passes through a neural network, and then finally we'll build a network with object-oriented PyTorch NN.module, which is really the standard way to use PyTorch. Let's take a look at the assignment from the last section. We were actually going to compute the mean of all of the images in the MNIST dataset. So the first thing you need to do is actually load up that dataset. Here you can see we can pick out an individual image. And then we're going to use a data loader to cut that into batches. And then you can see for each batch, all you really need to do is call .mean, and that's going to give you the batch averages. And then the overall average can be had from the mean. Now just for kicks, you should know that the mean of the means is not the same as the mean of the overall sample. You can work the math out and prove that to yourself. But here you can actually see the code to get the mean of the overall set of data without using batches to compare the difference. In this video, we'll have an introduction to neural networks. We'll look at machine learning and the difference between machine learning and neural networks, deep learning, and then we'll have a quick visualization to tie it all together. Okay, so what is machine learning? Machine learning is simply learning a function or program based on a set of known inputs and outputs. Rather than you figuring out the algorithm or memorizing it or coding it, machine learning actually computes the algorithm to solve your problem. Then what is a neural network? Well, a neural network is a specific kind of machine learning created from interconnected nodes. Nodes are typically modeled as tensors or multidimensional arrays, and interconnections are products or other mathematical combinations of these tensors. The tensors act together to form an overall network to compute an algorithm that's a solution to your problem. Then what is deep learning? Deep learning is an extension of neural networks combining multiple layers in sequence or a graph, enabling learning more complicated or sophisticated representations of data. Deep learning is advanced neural networks used to solve a wide array of problems. Here we can use the NetworkX Python package in order to create a network. This isn't exactly how a neural network works in practice, but it's a great way to create a visualization that you can modify in code. We're starting off by importing NumPy, Matplotlib, NetworkX, and the math library in order to get going, and then we're going to build a graph with NetworkX. This is a neural network that consists of three basic kinds of nodes: inputs, activations, and outputs, which you can see we're building here as Python dictionaries. Then after we have those dictionaries, we make a fully connected network. For every one of the inputs, we then loop through to every one of the activations, adding an edge from input to activation. And then from every activation to every output, we loop through each pairwise, and then add an edge from each activation all the way to each output. Then we can actually draw that network, which we actually do in the code here below, where we have NetworkX nodes, and then dense, and then all, with a little bit of node color. Dictionary above of star inputs, star activations, star outputs actually combines everything together into one overall list of nodes, which we actually use to get the keys. And you can see the graph is drawn, everything is fully connected. This fully connected graph gives you a visualization you can work with and experiment, adding more nodes, changing the colors, etc., so you can get a feel for what it looks like in practice. Now, in reality, we don't use a graph library to build a neural network or a deep learning library. We use tensors and then use the products rather than the edges in order to compute the outcomes.